In this video, we will be looking at how to determine the asymptotes of a rational function. First of all, the vertical asymptotes are found by setting the denominator equal to 0 and solving for x. Other asymptotes, you'll have three possibilities. If the degree of the denominator is bigger than the degree of the numerator, then y equals 0 is always the horizontal asymptote. So if our rational function is bottom heavy, the degree of the bottom is bigger than the degree of the top, y equals 0 is your horizontal asymptote. If the degree of the denominator is equal to the degree of the numerator, then the ratio of the lead coefficients will be the equation of the horizontal asymptote. And then if the degree of the denominator is less than the degree of the numerator by exactly 1, you will divide the numerator by the denominator and ignore the remainder. This will give you a slant asymptote, sometimes called an oblique asymptote. So let's look at a few examples. Our first example, we're asked to give the equations of any vertical, horizontal, or oblique asymptotes. So first, let's find our vertical asymptotes. Remember that the vertical asymptotes occur when the denominator is equal to 0. So we have x squared minus 16 equals 0. We can add 16 to the other side. We have x squared equals 16. Square root both sides, so x is equal to plus or minus 4. So we have vertical asymptotes at x equal positive 4 and x equal negative 4. Now the non-vertical asymptotes, you have to decide how the degree of the top and the degree of the bottom compare. Notice that the top polynomial is a first degree. The bottom polynomial is a second degree. Anytime that the degree of the bottom is bigger than the degree of the top, then you have a horizontal asymptote at y equals 0. We're asked to give the equations of any vertical, horizontal, or oblique asymptotes again. First of all, let's do our vertical asymptote. We have vertical asymptotes whenever the bottom of the fraction could be equal to 0. So 2x plus 1 equals 0. We'll solve for x. 2x equals negative 1. Divide by 2. X equals negative 1/2. So we have a vertical asymptote at x equals negative 1/2. Our non-vertical asymptotes, again, we have to see how the degree of the top and the degree of the bottom compare. Notice that the degree of the numerator is first degree. The degree of the denominator is also first degree. So whenever that's the case, whenever the degree of the top is equal to the degree of the bottom, then you have a horizontal asymptote at y equals, and all we want to do then is grab the lead coefficients, 3 over 2. So y equals 3 over 2, the horizontal line through 1.5 will be my horizontal asymptote. In this example, let's find our vertical asymptotes first. We find that whenever the denominator is equal to 0, so x minus 3 is equal to 0 when x is equal to a positive 3. So we have a vertical asymptote at x equals 3. Now for our non-vertical asymptote, we have to compare the degree of the top and the degree of the bottom. Notice on this equation, my top degree is bigger than the bottom. So in order to find this asymptote, it's going to be a slant or oblique asymptote. And the way we find it is by dividing 2x squared plus 5 divided by x minus 3. Now we can do this with a synthetic division, or we can do this with long division. If we do it with long division, we're going to need to put a placeholder in here because we're missing our x term. So let's go ahead and do that. X minus 3 divided into 2x squared plus 0x plus 5. And we're 2x squared divided by x will give me 2x. Multiplying 2x times x is 2x squared. And then 2x times negative 3 is negative 6x. Now we need to subtract. So algebraic subtraction, we change the sign and add. So positive 2x squared and a negative 2x squared cancels off. 0x and positive 6x is 6x. Bring down my next term. And 6x divided by x gives me 6. Multiplying 6 times x is 6x. 6 times negative 3 is negative 18. Subtract by changing the signs and adding. So positive 6x and negative 6x cancels. 5 and 18 is 23. But we will ignore the remainder. So our slant or oblique asymptote will be at y equals 2x plus 6. Now if we were going to do this with synthetic division, let me show you that we get the same thing. Remember with synthetic division, we change this sign, put that positive 3 in the little box, and then our coefficients, we have a 2 and then 0, 5. Bring down our first term. So 2, multiply, write it, add, multiply, write it, add. And then when we put our variables back in, since this was x squared, this will be 2x plus 6. This is my remainder, which I'm going to ignore. So y equal 2x plus 6 is what we got originally when we did it with long division.